Dear friends, welcome to the next session for software engineering and design concepts. So in the previous session, we completed with the requirement analysis and specification phase and described that the exit criteria for that particular phase is basically a software requirement specification document or SRS, which forms the entry criteria for the next state in the software development lifecycle model. And in today's session we will be discussing that particular stage, which is known as design phase, which follows the requirement analysis and specification phase. The entry criteria for the design phase is the software requirement specification document of the previous phase. So let us get started. So in the design phase, basically the SRS document is transformed into a form which can be implemented easily by using any programming language. It essentially does not mean that it is the SRS is converted into a program. However, it means that the SRS will be converted into a document which can then be converted into a program. A good software design is not achieved directly through a single step procedure. It involves a series of steps and iterations. So at every point of time you have to understand that the design has to be renewed and redesigned and created so that the requirements are met in the most effective manner. So SRS basically is dependent on design activities to be converted into a design document. These design activities can be categorized into various forms like object oriented design, function oriented design, as well as high level design, so that we achieve the maximum from a broader as well as from a detailed perspective. Now, what should be the components which we need to design during the design phase? The first one is the structure of the module. So the structure of the module essentially involves what type of the organization or what type should be the project, whether it should be a modular one or it should be a whole project, or how many modules should it have, or how many functions and functionalities can it be broken down into. All those things will be identified in the structure of the module, and we will get a full structure of the entire project, which will be showing us the dependency between various functionalities of that particular project. The next is the control relationship among the various modules. So the control relationship essentially means how the modules interact with each other, or in what ways are they dependent upon each other, whether these modules have a call relationship or an invocation relationship. So now let us consider that there are 3 modules in a particular project and they have this particular structure. So we have identified that the structure is basically this. It has a triangular structure. Now what type of relation will module 1 have with module 2, or module 2 have with module 3? So these things has to be identified well ahead, because it might be so that module 1 will be completely using up module 2, or it will just give a call to module 2, or it will just invoke some of the functions which are there in module 2. So all these things are maintained in the control relationship. The third important fact is what is the interface among the different modules. When we are talking about the interface, it essentially means the outward look of that module to the next module. So it might either be through a form, or it might be through some values, or it might be through various function calls that there are these interfaces get activated. The fourth important point is what are the data items that are exchanged between these modules. We also have to put emphasis on designing the data items that are required to be exchanged among different modules. The fifth point is what are the different data structures of the individual modules, because if data is involved, essentially there has to be a proper data structure by which we can handle that particular data. And then we have algorithms. So algorithms, again, they refer to the step-by-step procedure of implementing that particular functionality which resides in a module. So with all these aspects, we have to make sure that whatever we are designing in the design phase, they are documented well in a design document, both from the broad perspective as well as from the detailed perspective. When we are talking about broad perspective, we are essentially consider point 1, 2 and 3, because it gives us an overview of the entire project. And when we are talking about the detailed or a low level design component, we are talking about the final 3 points, which involves a detailed or description of the data structures and the algorithms that they are using. So moving ahead, the design essentially needs to be have a modular structure. So what do we mean by a modular structure? Each of the module or each of the projects consist of various projects and their associated data structures. Now if we write all of the requirements or all of the functionalities in one go, it becomes very difficult to comprehend the entire document, which means that it will become difficult for us from the understanding point of view in order to understand what is actually written there. So if we break it down into smaller chapters or smaller modules, it becomes easier for us to identify each of the chapters and each of the modules in a detailed manner. Let us consider this particular diagram that is shown. Suppose the entire project was written in module M1 and all M2, M3 and M4 and M5 and M6, all of them have different functionalities associated with it and different requirements associated with it. Now if all of them are written inside M1, it will be difficult for us to understand which functionality or which feature belongs to which particular requirement. So it is actually easy, and it is good that we break them down into various modules so that every module can be identified and worked upon carefully. Now each of these modules in a modular structure will have their own set of definitions for data, functions and algorithms. So now whenever there is a bug or a error or any problem associated with any of the requirements, we can simply refer to that particular module which is taking care of that particular feature. So once we can identify the module, it becomes easier for us to go to that module and make the necessary changes. Hence modular structure is of extreme importance when it comes to designing a particular design or designing a particular project. Now talking about the design classification, as already mentioned, design activities which we discussed previously as to what are the components that we need to design, so they can be categorized into two different classes. One is the preliminary or high level design, and second is the detailed design or more specific design. We have to understand that this preliminary or high level design is from a broader perspective and it gives you the entire structure of the project. However, the detailed design goes into more details of the project or more details of the modules, which involves various data and the data structures along with the algorithms that they are using. However, the scope and meaning of both these classified processes can vary from each other because both of them represents the project from two different angles. So we have to understand that whenever we are designing a particular project or we are converting an SRS to a design document, we need to put focus on both the strategies, both high level as well as detailed design. Now, first of all, we will discuss about the preliminary design. When we are talking about preliminary or high level design, as already mentioned, it should have the identification or the structure of the modules. Secondly, the control relationships among the modules, and third is the interfaces among the modules. So when we are talking about the project, we have to identify how many different types of modules we can associate or we can break down the entire project into. We also have to identify how these modules are related to each other, whether they are using up entirely the next, whether the entire module is using up the next module, or some part of that module is being used by the next module. So we have to identify whether it is a function call or it is just an invocation call. So all those things we have to identify in the control relationship. And thirdly, it is the interfaces among the modules. So what type of interfaces each of this module will have is designed well in this preliminary design. The outcome of this high level design is basically a program structure or a software architecture where the entire structure of the program is mentioned. We use several notations for representing this high level design. The one we saw a few minutes back is basically a structure chart or a tree like diagram. So this tree like diagram or the structure chart is very popular while representing a high level design, because we do not have to include the details of it, we just have to represent them from an overall or a broad perspective. Some other notations which can be used in order to represent this preliminary or high level design can be a Jackson's diagram or Warnier-Orr diagram. So when we look into this preliminary design from a diagram point of view, we will see that we achieve a software architecture where M1, M2 and M2, M3, M4, M5 and M6, all of them are modules and they are related to each other using the relationships D1, D2, D3, D4 and D5 respectively. We also have various interfaces between these modules. So when we look at this, we will see that M1 is essentially the root of the tree and M6 is essentially the leaf of that particular tree, and all of them are the child nodes. So this is like a tree like representation where M1 is the root as mentioned and M6 is the leaf. So the root is broken down into the child nodes and finally gets terminated in the leaf nodes. So that we already know, and this the same representation that like that of a tree can be used in order to represent a particular project from a broad perspective. So next, moving ahead to the detailed design. So when we are talking about detailed design or the low level design, for each of the module we have to design the various data that they are using, the data structures and the algorithms that they will be using. So these three important aspects will be dealt with in this particular design strategy, and we will get a first an idea about the various types of data types and data structures and algorithms that these modules will be handling. The output of this detailed design essentially is a module specification document where each of the module will be represented in terms of the algorithms, data structures and data that they are handling. So both these design strategies are extremely important from the perspective that we get a broad perspective of that entire project as well as the detail level perspective of the entire project. Detailed design can also be classified into procedural and object oriented design. Now procedural essentially deals with the function oriented aspect, which means it will be showing you the different functions each of the module will be handling, and object oriented design will be basically dependent upon the various objects and their attributes that particular module is using. Some of the more recent aspects which are related with detailed design are aspect oriented design and component based design. Now, aspect oriented design refers to the various aspects by which the various data structures would be used and various algorithms would be used, and component based design essentially means the client server interaction or the network related design activities. So we will do this more in more detail when we do our subsequent sessions. So now when we are talking about analysis, so what is the difference between analysis and design? Though both the words means almost have a correlated meaning to it, but they also vary from each other with a huge difference. Basically, the analysis technique helps to elaborate the customer's requirement through careful thinking, and at the same time consciously avoids making any decisions regarding the implementation. So analysis basically refers to the brainstorming sessions with the customer, but it will not include any of the aspects which will be related to implementation or coding. However, the design model is obtained from the analysis model through transformation over a series of steps, and the decisions regarding implementation are consciously made. So coding and implementation basically is related to the design document or design phase. However, analysis will have no direct emphasis on implementation or coding. It has to be converted into a proper design document because before it could be actually implemented. But whenever you think it from a literal point of view with analysis and design, it means that we almost come to a similar type of conclusion that we are making a particular design using our analysis. That is true, but analysis from the perspective of software engineering essentially means that you will be involved only with the brainstorming sessions, giving proper suggestions and making proper analysis of the customer requirements, and carefully avoiding anything which is related to coding and implementation. However, design document is exactly the opposite of your analysis, where you will be focusing more on the implementation part and less with the customer requirement brainstorming sessions. Now, when we are talking about designs, how do we categorize that a design is good or bad? Now, there is no unique way to design a particular system, and please remember that whenever we are designing something, it can never go wrong because it is from your own perspective, keeping in mind that your notations are correct. So when we are talking about a good design, all designs are good if the aspect could be particularly justified. Even using the same design methodology, different designers can arrive at different design solutions. No two designs will be similar or same if two designers are asked to design the same project. However, both the designs are not wrong as well. So we need to distinguish between good and bad designs. However, we have to keep in mind that all the designs are not entirely wrong, but we have to identify certain flaws associated with each of these designs. So a good design properties essentially should implement all the functionalities of the system correctly, should be easily understandable, should be efficient, and should be easily amenable to change, which is easily maintainable. And we should be using consistent and meaningful names. That means the notations should be correct. Also, we should make use of abstraction and decomposition principles in ample measure. So we have already discussed about abstraction and decomposition in our previous sessions. So we have to use those principles in ample measure in order to provide a very concise, crisp, and correct design strategy or correct design document. So this is all for today. Thank you.